Hello, my dear students. Good afternoon, all of you. Welcome to video class. Today we are going to complex numbers. In complex numbers, argument of a complex number or amplitude of a complex number concept. So, what is the amplitude of a complex number? Amplitude of a complex number. So, how to define amplitude of a complex number? It is also called argument of a complex number. How to define that? Let us see. To define, I take the complex plane. It is also called orgone plane. So this is called real axis. Real axis. Horizon. Vertical, this is called imaginary axis. So it is called a complex plane or orgone plane. Now in complex plane, how to define amplitude or argument of a complex number? Take the any point P here. Let P A comma B. Let a point P A comma B represents a complex number Z. So this is how to represent. This is nothing but A plus iota B, represents in a complex plane. Now join OP. These two are intersecting at the point O. So here angle is formed. What is the angle? So here this angle is called actually amplitude of a complex number. How to define this angle? Let P A comma B is any point or is a point represents on a complex plane. Then the angle theta that which makes, that means the angle that the line OP, this line OP makes with which axis? Real axis. Makes with real axis. Taken by what here? In which direction? This is called positive direction. It means anti-clockwise direction. That is called amplitude of a complex number or argument of a complex number. Shall I write the definition? Okay, all of you note this one. Let a point P A comma B represent a complex number Z. A complex number Z. Then the angle theta, then the angle how to define angle here? Then the angle that the line OP makes with real axis. Which axis? Real axis. Makes with real axis is taken in anti-clockwise direction. Anti-clockwise direction is called, what do you call this one? Amplitude. Amplitude or argument Argument of a complex number z. Argument of a complex number z. How to denote this one? And denoted by shortly, this is denoted by amplitude of z, that is amp of z, or else arg of z. This is equal to what? Theta. This is called amplitude of a complex number. All of you remember that this OP line makes angle theta with the real axis in anti-clockwise direction. Then theta is called amplitude of a complex number or argument of a complex number. How to define here principal amplitude of a complex number? So how to define principal amplitude of a complex number? Actually this, remember all of you, amplitude value or argument of z always lies between 0 to 2 pi here. So remember here, note arg of z lies between 0 and 2 pi actually. Total rotation is equal to 0 to 360 degrees. So arg of z lies between 0 and 2 pi. But how to define principal amplitude of a z here? How to define principal amplitude of z? This is very important. Principal amplitude of z. What is the principal value of amplitude of z? So if theta lies between minus pi comma pi, this is called principal amplitude of a complex number or principal argument of a complex number. So theta either open interval or closed interval, whatever it is, both satisfied. If theta lies in open interval minus pi comma pi, if theta lies in minus pi comma pi, then it is called principal amplitude of a complex number. How to calculate principal amplitude of a complex number? So to define principal amplitude of a complex number, let us see here. So we define here, let P is the point, that is A comma B. This is imaginary, this is the real axis. So OP, this OP makes an angle theta with the positive real axis. Okay, real axis that is. Now from this we have to draw the foot of the perpendicular to the real axis, that is PM. How much angle subtended here? 90 degrees subtended. What is the OM? OM is what? A, that is real part on real axis. OM is equal to A. So what is the PM? That is B, because this is imaginary part on imaginary axis. This is the OM and OA. Can you define here? We studied here. If it is a right angle triangle, yes, it is a right angle triangle. In right angle triangle, what are the finding? Trigonometric ratio. What is the easiest ratio, convenient value? We know the opposite side, we know that, adjacent we know that. So what is the finding ratio? Tan theta. From this, tan theta is equal to, from the triangle, tan theta is equal to, what is the value? Opposite. Opposite is B divided by adjacent A. This means what? What is the B? B is called imaginary part of Z. What is the A? A is what? Real part of Z. So from this, theta is equal to tan inverse of B divided by A. This is the amplitude of a complex number. To define amplitude of a complex number, what is the formula? Theta is equal to tan inverse of imaginary part of z divided by real part of z. You keep in your mind, principal or amplitude of a complex number always depends on a quadrant which lies. How to define here quadrant here? So principal amplitude lies between minus pi comma pi quadrant. So here remember, if p lies in the first quadrant means here what? Sine, cos both are that is here. Sine is positive. All silver teacups, we know that these things. Simply A is positive, B is positive. Simply remember, A positive, B positive in the first coordinate. So what is the amplitude here? Theta. Does it lie between minus pi comma pi? Yes. Hence, in the first coordinate, what is the principal actual amplitude of z? Theta only. If you take in the second coordinate, observe all of you, this is the point P. If the P lies in the second coordinate, what is the angle here? What is this angle? 180 minus theta. 180 minus theta. Does it lie between minus 180 and plus 180? Yes. It lies in the minus pi comma pi. So actual amplitude of z is equal to pi minus theta. Suppose if the point here lies in the third coordinate, point P lies in the third coordinate. So calculate this one. So this is the angle. This angle is equal to what? Pi plus theta. This total angle is 180 on the real axis plus this angle theta, pi plus theta. Does it lie between in the principal interval? Principal amplitude of interval? No. So how to bring this one in the interval minus pi comma pi? How to bring this one? In this case, we should follow in clockwise direction. So pi plus theta is also equal in clockwise direction, minus of pi minus theta, or else theta minus pi. In clockwise direction, this becomes pi minus theta. In clockwise means negative symbol. This is the third coordinate. In third coordinate, what is the actual amplitude of z? Minus of pi minus theta. If the point P lies in fourth coordinate, so what is the actually 2 pi minus theta, but doesn't lie between in actual principal value. So taking clockwise direction, this angle is what? Minus theta. So remember, amplitude of a complex number always depends on the coordinate in which lies. So how to remember these things? This is the concept, but you remember, I will give the short tabular form, that is, all of you remember here. So complex number, I take the note like this tabular form. So this is the complex number here. I take simple table here. This is the quadrant. Which quadrant here? A greater than 0, complex or otherwise simply we can write here. Let z is equal to or p is equal to a plus b iota, where a comma b are real numbers. The first point here, remember, amplitude of z. Amplitude of z is equal to theta. So when it is this one theta, if z meaning what? P here, remember all of you. If z lies or p, if z lies in first quadrant, that is, remember, a greater than 0, b greater than 0. Imaginary part greater than 0, real part also greater than 0. Second point, amplitude of z is equal to pi minus theta. Amplitude of z is equal to pi minus theta. This is if z lies in second quadrant, that is A is always, observe that, less than 0, B should be greater than 0. Real part negative, imaginary part positive. Third one, amplitude of z is equal to minus of pi minus theta. This is if z lies in third coordinate, that is if A less than 0, B less than 0 in this case. Both are negative. Next point, amplitude of z is equal to minus theta if z lies in fourth quadrant. If z lies in fourth coordinate, then in this case, that meaning here A is greater than 0, B is less than 0. So if you remember this table, we can easily find the actual amplitude of a complex number. All of you remember, if z lies in the first coordinate, point lies in the first coordinate, amplitude of z is equal to theta. If z lies in the second coordinate, argument of z is equal to pi minus theta, second coordinate that is. So I showed these all things here. At least if you are not understanding these things, you remember these points, we can easily solve the questions. If z lies in third coordinate, that is amplitude of z is minus of pi minus theta. If z lies in fourth coordinate, amplitude of z is equal to minus theta. All of you remember this table, it is very, very important. Now formula, what is the amplitude formula, remember? So if z is equal to a plus iota b, a comma b are real numbers, then theta or argument, amplitude of z, also called argument of z, shortly theta. What is the formula? Tan inverse of, take the acute angle always, mod b divided by modulus of a, mod of b divided by mod of a. This is also written as tan inverse of mod of imaginary part of z divided by mod of real part of z. So this is the formula to find the amplitude of a complex number. To find the actual amplitude, these are only. Why? Because these are depends on the quadrant. With the help of this, we can solve the questions also. How to solve one by one problem also. See the problems here. The question is, find the amplitude of, find the amplitude of, find the amplitude of z is equal to 1 plus iota. How to find amplitude of a complex number z is equal to 1 plus iota? The first step, take the complex number. So that is z is equal to 1 plus iota, it is a complex number. We have to find the point in which coordinate, that is important here. So take the a, comparing with, always comparing with a plus iota into b. In this 1 plus iota, what is the real part? the real part is 1. So here A is equal to 1. Is it positive or negative? Simply it is a greater than 0, positive. What is the coefficient of I? That is 1. Take as imaginary part. B is also 1, which is greater than 0. Observing, if A greater than 0, B greater than 0, then Z lies in which coordinate? First coordinate. So from this, clearly we have to say Z lies in first quadrant Q1. It means what? Cos is positive, sin is positive here. All are positive in the first coordinate, all positive. So Z lies in the first coordinate. The second step, find the theta value. So we know that formula. We know that theta is equal to tan inverse of mod of B divided by mod of A. This is the imaginary part by real part. Tan inverse of mod of 1 divided by 1 is equal to tan inverse of 1. Do you know this value? Yes, from the inverse trigonometry, tan inverse of 1 is equal to pi by 4. If Z lies in the first coordinate, what is the actual amplitude of Z? Actual amplitude of Z is what? Theta. Therefore, amplitude of Z is equal to pi divided by 4. This is the answer of the question. Similarly, if I take the Z number, are you following this method? Same procedure is applicable in all cases. What is the here working rule? Observe that. Take the complex number comparing with the A plus iota B. Next, identify the quadrant. Quadrant means first quadrant, second quadrant, third quadrant, fourth quadrant. Third step, find the theta using tan inverse of mod of B divided by mod of A. Then according to quadrant, so actual amplitude of Z calculate. For sake of understanding, I will give the one more example. Second problem. Find the amplitude of Z is equal to 1 minus iota. Find the amplitude of, just simply here, change it here, conjugate, 1 minus iota. How to solve? Let us see. Do the procedure, follow same working rules. Take the given complex number, 1 minus iota. Next, comparing with 1 A plus B iota. Find A here. What is the A? A is what? Real part. That is 1 which is greater than 0. And B meaning what? Coefficient of I. I sahagunakam. What that is? Minus 1. With symbol important here. B is equal to minus 1 which is less than 0. Now go through the table. A is positive. A is positive, B is negative. Go through the table here. First one, second, third, fourth. Observe that. A positive, B negative. That means what? Z lies in the which coordinate? A positive, B negative. So Z lies in the fourth coordinate. So that is Z lies in Q4. Z lies in the fourth coordinate. Then follow the next step. What is we know that theta is equal to tan inverse of mod of B divided by mod of A. This is equal to tan inverse of mod of minus 1 divided by mod of 1 is equal to tan inverse of 1 is equal to pi by 4. But actual amplitude of Z, Therefore, amplitude of Z is equal to, Z lies in which coordinate? Fourth coordinate. In fourth coordinate, what is the actual amplitude? Minus theta. That is minus pi by 4. This is the answer. Similarly, we have to solve some more questions also. See the next question, fourth question, third question is same model. Find the argument of Z is equal to minus 1 minus I theta. Minus 1 minus I theta. Follow the method. We do not change here. Solution is Z is equal to minus 1 minus I theta. Now comparing with A plus B iota. What is the A value? Very simple. Here A is equal to minus 1, which is less than 0. And B is also I coefficient minus 1, which is less than 0. Now go through the table. A negative, B negative. So what do you say that? Z lies in, point lies in third coordinate. If Z lies in third coordinate, find the actual amplitude of Z. So firstly calculate theta value. We know that formula. Theta is equal to tan inverse of mod of B divided by mod of A. Substitute here. Tan inverse of mod of B value. What is the B? Minus 1 divided by mod of minus 1. This becomes tan inverse of in modulus negative becomes positive. Tan inverse 1 is equal to pi by 4. But actual amplitude of Z, what is the formula? Actual amplitude of Z is equal in third coordinate minus of pi minus theta. Minus of pi minus theta. Substitute here minus of pi minus pi by 4. Pi minus pi by 4 is equal to 3 pi by 4. Minus 3 pi by 4 is the answer. Similarly, we find the Z is equal to minus 1 plus I theta. So like so many questions are there. On tomorrow class, I will give the number of questions and properties based on complex amplitude of a complex numbers. Today, this is enough. So we have to learn all of it today, practice. What is the amplitude of a complex number? So that is theta is called amplitude of a complex number. And arc of Z always lies between 0 and 2 pi. What is the principal amplitude of Z? How to define? To define principal amplitude of Z, it lies between minus pi comma pi. Theta lies in minus pi and pi. From this, we can calculate theta. Theta is equal to tan inverse of B by A. Now, actually, amplitude of a complex number depends on the quadrant in which lies. So, quadrants here. So, according to if A negative, A positive, B positive, then Z lies in the first coordinate. In first coordinate, amplitude of Z is theta because it lies in the principal amplitude. If A less than 0, B greater than 0, it means Z lies in the second coordinate. In second coordinate, actual amplitude of Z is pi minus theta. It is also lies in principal value. Third coordinate, Z lies in third coordinate, amplitude of Z is equal to minus of pi minus theta. So this is lies in the actual amplitude of principal value. If Z lies in fourth coordinate, amplitude of Z is equal to minus theta. All of you remember. It is also called argument of Z. So to find the theta value, formula, tan theta is equal to tan inverse of mod of imaginary part of Z by real part of Z. Then solve the questions. Procedure this is only. On tomorrow we have to solve more questions. Okay. Thank you.